Okay. All right. So this one, what we could do is we could use the rational zero test. Now, I'm not going to go through all the rational zeros, but the rational zero test is basically your plus or minus your P. Well, I'm just going to write it down. So, okay. And that's going to be factors plus or minus of your P over your Q. Okay. So one thing you can do is you can always test if you can use synthetic division and it gives you a remainder of zero, that means that that means that value is a zero of your polynomial. Well, two values that are always going to work for the rational zero test are 1 and -1. So let's go ahead and try this. So I'm going to do +1 and -1, and these usually can be done very, very quickly. So that's why it's like, it's not too difficult. And I can see also I could do 2 and -2. Those would also be two potential zeros. I just don't know how much time I have. So let's try these two. All right, so bring down the 1. We're going to do some synthetic division. 1 times 1 is 1. Let's say it's a -4. -4 times 1 is going to be a -4. Let's see, 22, that's going to be 44. That's going to be negative, sorry. What am I doing? -4 to that, you add these up. So that's going to be a -26. And that gives you a -26, so that gives you a 30. So that doesn't work. And let's just pretend if that was a -1. Why do I keep on doing this? All right, so let's try this again now with a -1. I don't think this is going to work though. Bring down the 1. 1 times 1 -1 is -1. That becomes a -6. -6 times 1 is going to be -6 times 1 is a +6. That's going to give you a -18. -18 times a -1 is going to be a +18. That's not going to work. Okay, so that's going to give you a remainder. Let's try 2. See what happens. All right, so it's 1, -5, -22, 56. All right, bring down the 1. 1 times 2 is 2. -3. -3 times 2 is going to be a -6. This is going to give you a -28. Oh no, -56. What do you know? That's a remainder. So again, these are going to be potential rational zeros. And the reason why these are rational zeros is because these are factors of your P over your Q. So I don't have time to go through the rational zero test, but typically 1 and -1 always, you can always test these. And then not always is 2 a possibility, but it works for this equation. So therefore, there is my remainder. So that's good. That's my constant. That's my linear, and that's my quadratic. So you have an x squared minus 3x minus 28. And if you need to find the remaining zeros, you need to say what two numbers multiplied to give you -28, and then add to give you a -3. So 7 and 4 looks like it, right? So what about x minus 7 times a x minus 4? So therefore, my zeros are x equals 2, right? Because that one worked through the remainder. Actually, let's do it here. So 2, 7, and 4. Because if you were to set these equal to 0 and solve, that's what you get. So there you go. I haven't done that in a while, but glad that one was quick.